Hello everyone, in this demo I'm going to go over a small inventory script, a PowerShell script that allows you to query a bunch of servers at the same time and gather a bunch of information. The point of this tutorial is to show you how to build a real-world tool. So what we're going to do is the title of the demo is Building a Server Inventory Script a Good, Better, and the Best Way. So we're going to go down through from one way to get the job done, to a better way, and then finally to the best way. Our mission in this tutorial is to create a PowerShell script to pull lots of different information from a bunch of Windows machines. This report will serve as a quick way to find lots of information about servers in your environment. So for the steps, we're going to go through generally a 3-step process. The first step in this script is going to get a list of the remote computer names. Now, I'll be using statically defined computer names in the script itself, but you can pull these from Active Directory, a CSV, a database. It doesn't really matter. And the second step is we're going to check each computer for all kinds of different attributes. So things like the computer name, profile size, IP address, operating system name. The checks themselves really don't matter, but we are going to be using those as an example. Once you see the examples, then you can easily plug in your own. And then finally, to top it all off, we're going to build an HTML report. So we're going to take the report and then export it into an HTML file to give a nice, pretty report. All right, so I'm going to first collapse all of these regions here, because the demo script can be pretty big. So just so we can narrow this down and only do one of these at a time. So this is how the demo kind of structure is going to go. You'll see that I have different regions for different areas. We're first going to go down through each of these regions. Then we're going to do a single server. We're going to first get the prereqs and the lab set up. Then we're going to grab all of the tests, all of the code that's going to be needed for a single server. Then we're going to take the first good approach. The first good approach is just getting a single object back, one server per row. You'll see what I mean in a minute. Then the better approach, we're going to make it a little bit better by eliminating some code duplication. And then the last best approach is we're going to combine all that into a single script block. We can run it all one time on each computer. And then finally, we will add support for multiple computers, which you'll see is really easy if you get it going. And then finally, we're going to create the HTML report. So that's kind of how the tutorial is going to go today. First up, prereqs and the lab setup. So I do expect you to have some sort of intermediate PowerShell knowledge. This isn't a PowerShell 101 tutorial by any means, so I do expect you to have at least some PowerShell knowledge. I will be using PowerShell Core 622 on Windows, and we will be using PowerShell remoting extensively, so I'll expect you to have PowerShell remoting set up both on the client and also on all of the machines. And you see here I have some information about how to do that. And then one of the checks we're going to do is pull all of the user profiles on the machines. And for that, you will need SMB access on the computers. All right, so without further ado, let's get into the code. First up, I like to write the code for everything for a single individual server. You can't just go and just write a bunch of code for a bunch of servers at the same time. You need to figure out the code to do for each individual one. So let's do that now. The first thing I'm going to do is I'm going to define an IP address. This is just a single server. I'm not on Active Directory, so I don't have any DNS set up. This is a single server, and I will be needing a PS credential object because I need to pass that to connect to the remote computers. So let me bring this into my session and provide my username and password. All right, next up, I'm going to pull the user profile size. The user profile size is just all of the folder size of all of the user profiles on a particular server. And to do that, I can just run get child item against the users folder on each server. And I'll do this kind of individually here. You can see that it pulls down Atom and public. I just have 2 profiles there. And then I can pull down all of the files and recurse through all of the folders by running that, and you'll see that I have a bunch of stuff in there. I'm just going to enumerate all of those. We need to get the total size for all of them combined together. And to do that, I can use the measure object commandlet. The measure object commandlet groups together all of a particular property on there, and then using the sum parameter, I can then merge all those together and add all those up, which is the property length, which when you're calling a file from getChildItem, the length is always going to be the file size. And then since we only need one number, we just need the total. I'm then wrapping this in parens here, and a dot sum, I'm referencing the sum property. So first I'm going to assign this to a variable. And then once I've done that, let me see what this looks like. You see that it's 1911357, blah, blah, blah. A really long number because it's actually in bytes. We need that in gigabytes. To do that, I can use the math type accelerator here and use the round static method, passing the type of passing the bytes, the total bytes, which is the user profile size, divide those by 1 gigabyte. This is a really cool feature here. You can divide things by megabyte, gigabyte, kilobyte, and everything like that. And then I'm only going to do 1 decimal point here, so that's what that means. So whenever I run that, now you can see it's 0.2 gigabytes, so it's 200 megabytes. It's not too big. All right, so that is the first check. Next check, we're going to get the IP address. To get the IP address, we need to use sim or WMI. And to do that, we can use the get sim instance commandlet. Pass it the computer name parameter and specify the server, which is the one server that we're working with now. The class name is Win32 network adapter configuration. That sim class has IP address, IP enabled, default gateway, lots of different network information. And since there could be multiple ones like Bluetooth adapters and VPN adapters and everything like that, I'm setting a filter here for IP enabled equals true to only get me the ones with the IP address that I'm looking for. And then finally, I'm putting this in parens again, specifying the IP address property because I only want the IP address. And because there may be more than one in an array, I'm then doing a 0 here to get the 0 index of that collection. All right, so let's run this, see what happens. Okay, 10005, that's perfect, because if server were a DNS name, we would actually need that, but since server is an IP address, they're the same thing. All right, moving on. Operating system name. Operating system name is again found in SIM. We can find that in the Win32 operating system class. And since I want to find the caption property, I'm again encapsulating all that in parens and then getting the caption property. So now let's run this and see what happens. Hopefully we can get back the operating system name. Yep. In this instance, it's Microsoft Windows 10 Pro. It's one of actually the machine I'm working with here. All right, moving on. Memory. Win32 physical memory, same thing. We get it from SIM. And this time, since there could be different memory banks, so let me show you what that looks like. There could be different instances that come back from this call. So now you can see that there is, looks like there's 2 there. See that there's a space there? There's 2 instances, so we need to combine those together. And looking down through here, I can see there is a capacity property. Where is the capacity property? Oh, there it is. Capacity property. That's the one that shows the size. Using measure object again, we can group those together, sum those together, and then divide it by 1 gigabyte because we want to show physical memory in gigabytes. All right, bringing this down, see what that looks like. 7 gigabytes. Look, I think there's 7 gigs, and that's this machine here. All right, total disk space, again, same thing. Win32 logical disk this time, same thing in SIM. And in this time, I'm not going to go through this process that much, but I am using a concept called calculated properties. So you'll see whenever I run this, I'll show you some of this output. You see that I have different devices or different drives, drive types, volume name, and the sizes. I want size. So what I've done here is instead of kind of do the same thing up here, I've taken a different approach. By specifying the free space, I'm actually defining my own free space property here because there is not a free space property that includes all of this information. So you can see here I have free space down here. It's in bytes. However, I want that in gigabytes, and I want to round that to the first decimal. And I'm doing this here by specifying the expression. So you'll see, I'll just run this here to show you do this, see what happens. I think I can run that individually. Yep. So now I have device ID and free space, just the information that I'm looking for. And because I want the sum of all of the free space for all of the drives, I'm again passing that to measure object and then providing the free space property and finding the sum that way. So now whenever I bring this in, that should return a single value that we get in the report. So yep, we have 211.5 gigabytes of free space across all the drives. All right, then finally, the last check is the number of stopped services. So I want to find all of the services on that remote machine that are stopped. And to do that, I'm using invoke command here because in Windows PowerShell, get service has a computer name parameter. Unfortunately, in PowerShell Core, it does not. So you kind of have to wrap that get service invocation inside of a script block and then pass that to the remote machine with invoke command. So I'll run this and make sure this all comes back well. 146. So there's a lot of services stopped. All right, so that's kind of the gist. So the first thing we do whenever you build a tool, you have to figure out, just kind of tinker around with the code and just figure out what does what and what parameters use, what syntax there is to get the output that you want just for a single server. The next thing that we want to do is, since we're going to do this we want to report. So the report's going to have server name, all this information, one per row. So we need to output a single object so we can bring those in. Then the object will have all of the different properties. So to do that, I have created a hash table here called output. And you'll see that it has all the different labels of all that information that we did up here. We actually grabbed the code. We didn't assign it to anything. We were just figuring out the code up here. And now for this framework here, I'm creating a hash table. And inside of this hash table, I have labels for each of those checks that I want to define. And then here on 98, I'm casting it to a PS custom object. And you'll see that when I just run this, you see that I have a single object with all of the properties that I'm looking for. We're going to fill in all of those values here in just a minute. So now at this point, I'm essentially just taking the code that I already built, because I already built all that code. I'm assigning those values to each property. So I'm not going to go through that and this in any detail, but I want to show you that it sees output dot this, output dot that. I'm assigning those to each properties. So I will go ahead and run all these, and that will assign all that code that we just came up with to the properties. And now whenever I cast this to a PS custom object, now you can see that we have a output that we want. We have all the information that we're looking for all in one single object. We brought all that together. So that's kind of the good approach, I guess. The next approach is, I want to show you why I call that a good approach, because notice up here, get sim instance computer name, computer name, computer name. I have a lot of duplication. There's a ton of duplication here. If I change the server, I could change the server up here. But let's say that, I don't know, I needed to add a different parameter to all of these. I would have to do all these individually. To writing a great tool and writing great code, you need to practice the drive principle. Do not repeat yourself, and try to refactor it in a way that you can only make one change and that will cascade and affect a lot of other things. So let me show you the better approach here. All right, so we're on to the better approach. All right, for this one, since we're still using sim, I can use new sim sessions. So up here, every time I was calling get sim instance, I was calling a different session. So it would go out, connect to the computer, gather all the information and bring it back. Then it would go out, connect to the computer in, grab all the information and bring it back. This was creating little, I guess, ad hoc sim sessions. What we can do to make this more efficient is create one sim session, make the connection. We don't have to authenticate every time like we were earlier. And then once you have that one sim session set up, then you can just call that sim session over and over again. And I think I forgot the credential here, so let me add that in. And let's make sure this works first before we get too far. All right, yep. And then now notice that I am also setting the this get sim inst params to a hash table. I'm going to using splatting. So not only am I sharing that sim session across all of the computers where you don't have to authenticate every time, I'm also going to be sharing the parameters to the get sim instance as well. So looking down here, now notice that I'm using at get sim inst. Oh, looks like I forgot one here. Let me add that one. This is what happens whenever you refactor. You forget to add certain things. There we go. So now each of these has a shared set. I'm sharing the session and I'm sharing the parameters. Now if I wanted to, I go up here and add a different parameter and it would affect all of those inside of the block. All right, so now, again, we're using the same checks. We built the code. We are grabbing all that. That looks good. All right, so let's see if this works. So far, so good. Return the object. It should return the exact same thing, and it does. So that's perfect. So now we've kind of refactored it and made it a little bit better. That's the next approach. This is a typical approach that you will see whenever you're building a tool like this. All right, and then finally there at the end we do need to remove the sim session because if we created one explicitly up here, that sim session is held in memory. I can actually do get sim session, I believe. Yep, it is in there. So we need to remove that sim session to free up memory. It's always a good practice to do that. There we go. Okay, finally, for the best approach. Now I call this the best approach because all of the checks that we're doing up in the previous two instances, we were going out making a check, Even if we were sharing the sim session, we were still having to reuse that sim session over and over and over again. We were just remotely serializing and deserializing information across the wire. Using invoke command and PowerShell remoting, we can encapsulate all those checks into a single script block and then just call that entire script block at once for each one of the remote computers. To show you how to do that, here in 174, I'm defining the script block, and here I'm defining all of the same, pretty much the same code. However, there are a few instances that need to change. One of them here, I forgot this. Here we go. I always forgot that thing. All right, go back. There we go. So notice that we have a script block equals curly brace, and then everything that I'm going to be talking about from here down to 204 is all in that script block. You need to know that's important. Now here, notice that because this code in here is going to be running locally on the machine, we're not actually going out and remotely checking something. We're running all this locally. We need to write the code like we're locally running on that console itself. So server name, instead of pulling out a server name from the loop that I'll be doing, I'm just using the host name command. And the host name, all it does is just return the host name of the current computer. And then on 188 here, see, instead of using the UNC path, I don't even need SMB share access or SMB access at this point. So this is running locally on the machine. I'm just checking C users. I don't have a computer name parameter here. I don't have any sim instance. I don't have any of that stuff. All of that is gone. I don't have to deal with any of that stuff anymore because this code is running locally on the machine. And then finally, I'm outputting it as a PS custom object like I have been before. So now let's define this script block. This is all one script block. So it's kind of like a little package we are delivering to the remote server. Maybe like a care package. All right, next up. We're only going to do one server at this point, specifying the computer name as the server name that we're currently working with, the script block parameter, which is the script block and all that code that we just copied and pasted in, and then the credential. Since we're not in Active Directory, we need to provide the credential. We can pass all that to invoke command, and we'll do that by splatting here. We are saving some line space here by splatting. So let's run this and see what this looks like. All right, so notice that we have actually server. You know what? I may have actually jumped the gun here. Notice that we have server name, win server 19, and we have win 10. I may have jumped the gun a little bit. Let's see what server is. So, oh, yep, I think I did. I jumped the gun a little bit. Copy that over. Shh, pretend like you didn't see that. There we go. Just win 10. I don't know what that other stuff is talking about. All right. So, but notice that we've got PS computer name, run space ID, and you don't see it, but there's also a PS computer name and PS show computer name properties that invoke command returns here. I don't want all those other extra properties when I run it this way and invoke command. So I passed it all to select object and exclude the properties that I don't want. So now when I run this, I should just get back the information that I want. So now we got exact same information like we have. We're just encapsulating it all in a script block and then running it all in one shot. The beauty of doing that all in one shot is that you can easily expand that to multiple servers. With the invoke commandlet, you can specify as many servers that you want, and it by default will natively go out and invoke that, run that code in the script block on all the computers in parallel. There's some backend stuff that you can configure, but if you're just doing, I don't know, if maybe a few hundred servers or something like that, you can just blast it out, and PowerShell will run it on all the servers in parallel. To demonstrate that, instead of server, now I have servers. So I have two machines this time, and then I'm passing it to the computer name of servers. And all this code here is exactly the same as what we had before. So now I can run this. And now you can see WinServe 19, like you were not expecting that at all, and Win 10. Exactly the same thing. You notice it was just fast because I only did two, but it's really fast on dozens or even hundreds of computers. I've done this in production many times, and it's very, very fast. So that's the best way. Now we have built a tool to go out and query a bunch of servers at once in parallel. Let's take it a step further by building an HTML report. So right now we have all this output in the console. It's great. It's good information. We could do some things with it, like using format table, changing the output, but it's a really cool way you can create an HTML report. To create an HTML report, there's lots of different ways. So I'm just going to show you one way. With HTML, the sky's the limit. You can do anything you want, but for this information, I am providing some CSS here. You can provide CSS or HTML to the HTML that PowerShell outputs. So I'm creating a header. This is just essentially, it's going to create some colors of the columns and the titles and things like that. I'm not a big HTML guy myself. My friend Nick Rimmer actually built this HTML report for the blog post that this is going to be associated with. All right, bring that variable in, and now I have the same exact thing here, invoke command, doing the same thing, select property, excluding all the information, and then this time, see, I'm converting it to HTML, and I'm using the fragment parameter, which will allow, it doesn't include the main tags, like I believe it's the body tag of the HTML body. It's supposed to be just one HTML fragment. So let's see if this works here. We'll bring this in. Report. So now it doesn't look very good if you look at it in the console, but this is a nicely HTML text. Any browser can look at this. And to add the H1 tag, so I'm just defining a table, a title of server inventory or server information report, providing the post content, which is essentially the body, the HTML body, and then the head, which is the header, which is going to be at the head tag for in HTML. And then because I want to output this to a file, I want to view this in a browser, I'm then passing that to out file using the server report.html. All right, I run this, and that creates a server HTML file, and I can then invoke it in the browser. Run it in the browser, and voila, you have your H1 tag here, you have a green header bar, and it will provide all this information. Once it's in this information, you can add borders if you want and do all kinds of crazy stuff. And the beauty of this is you just simply need to add another check. So let's say that, I don't know, you just want to see if the server was online or not. You could just do online, true, false, true, false. You could just add columns to this as much as you want. Okay, so that's kind of the gist of the tool that I built. So now, once we have all of that information, all that knowledge, we can wrap it all up into a single script. I've created a script called Get Server Information, and this will be available on GitHub. And this is exactly the same thing we were just talking about. It encapsulates all of the best technique that I have. You can see here that it's all the exact same code, but I've made it customizable to where now you can pass in your own computer names and your own credential when you recall it. So let's see what this looks like. So now I have it stored in PS Server Inventory Demo. I can call it with a computer name, past servers. So I could, right now I have those two IPs in there. I could use, something like get content. If there's one server names per row, you could use Active Directory. Any way you can get a collection of server names to the computer name parameter. And then I'm passing the credential since I already have that. So now when I run this, ta-da! It's immediate. So I combined around 253 lines of code into a single one that you can provide the servers to, the server names, and the credential, and we'll go out and run all those checks at once in parallel. I really wanted to record this. This was originally a really long blog post, and I wanted to record a tutorial video on it because I really enjoyed writing the post. I got a lot of help from a few people on that, and I really think that this tutorial, this tool building tutorial, was a really good way to kind of encapsulate that and to also improve on what the original post had. Thanks for watching this demo.